We're going to talk now about multiplying rational expressions, and in our book this is problem type 2. And the difference between problem type 1 and problem type 2 is that problem type 1 was rational expressions made from two monomials. Here we have rational expressions made from binomials, trinomials, we have polynomials. The first thing we're going to need to do in order to simplify this is we're going to need to factor each of these expressions. So looking at the numerator of my first expression, a negative 2. I'm looking for factors of negative 2, or 2 rather, that are going to give me a difference of positive 1. So if I multiply x plus 2 times x minus 1, 2 and negative 1 are going to give me negative 2 when I multiply them, and positive 1 when I add them. Now, my denominator can't be factored. Then I'm going to factor my second expression. My numerator is x minus 3, can't be factored. But my denominator is 3x plus 6. Now I can factor a 3 out of that term, and I'm left with 3 times x plus 2. The next thing I want to do is I'm going to look at everything I have. Anytime I have something in either numerator that matches anything in either denominator, I can cancel those. So as you can see, I have an x plus 2 and an x plus 2. Those will cancel. X plus minus 1, x minus 3, x minus 2, and 3. I have no more matches. Nothing else will cancel. So then I multiply, which basically just means write everything you have down. That is completely simplified, and we're done with that. For our next example, we have another problem very similar. My numerator can't be factored, but my denominator has a 3 that I can factor out, and I'm left with 3 times x plus 1. This numerator, I have negative 3, so I'm looking for factors of 3 with a difference of 2. And since I want that 2 to be negative, I'm going to have my 3 be negative. So x minus 3 times x plus 1, because negative 3 and positive 1 will add up to negative 2. In my denominator, again, I have negative, so I'm looking for a difference. So I'm looking for factors of 6 that have a difference of 1. 2 and 3 multiply to make 6 and have a difference of 1. Since I want my 1 to be positive, I'm going to make that 3 positive and my 2 negative. I'm looking for things that will cancel. In this numerator I have x plus 3, which will cancel with this x plus 3 in the denominator. Here I have x plus 1, which will cancel with x plus 1 in the numerator. There's nothing else that cancels, so I simply write down whatever's left. So I'm left with x minus 3 over 3 times x minus 2, and that problem is complete and simplified.